All right, let's implement PPMI together. First, we need to make a PPMI matrix, and that will have the same dimension as the co-occurrence matrix. However, the data type should be float rather than integer. And to calculate the total number of occurrences, we need to sum all the components. And we are going to calculate each word's occurrence using this expression. And total, here, we're going to get another parameter, verbose. Because calculating PPMI takes quite a long time, if this verbose is true, then it's going to print out how long it has, how much it needs to do more, okay? So total is the C dot shape 0 times C dot shape 1. And count is 0. So these two are for print out the progress of this function when verbose is true. For we first need to calculate the PMI. It's going to be log 2. Cij indicates the co-occurrence, number of co-occurrence, and we need to multiply this value by n, and we need to divide this value by Sj times Si. And we're going to add epsilon for numerical stability. And PPMI becomes maximum between 0 and PMI. And we're going to put I and J, PMI like this. And if verbose, we're going to increase count. And if count reaches certain values, we're going to print. We have done up to this point like this. Okay. We're going to return M. All right. So let's test this PPMI implementation. We pass our co-occurrence matrix. This MP set print options defines how many numbers after the dot. What is that? I don't know how to say that. Anyway, let's print out C. Maybe there's something wrong. MP0, not zeros. Zeros like. Okay. So it's printing out the correct results. Okay, we also need to talk about dimension reduction. How can you do this? We're going to use singular value decomposition. That is very simple because NumPy offers linear algebra library package, and we can just call SVD like this. And we can just print C0 co-occurrence PPMI and reduced one. And to reduce the dimension, it's quite simple. We just take the first two components, and that's just reducing the dimension, okay? And another thing I'm going to do here is how we can plot or visualize words. PLT, we can use PyPlot. Like this, and PLT scatter view. In this way, you can visualize words on a 2D space, okay? Up to this point, we've discussed count-based methods with a very, very simple data set. I can't even call it a data set because that was just a simple sentence. However, we cannot use Wikipedia or Yahoo News data set because they are too big. And what we are going to use here is a medium-sized data set, PTB data set, Pantry Bank data set. I'll just give you the code to pre-process and get this data set. So after this class, play it on your own. First, define the window size as 2 and word back size as 100. And we can get corpus word to ID to word by calling load data string like this. Vocab size is len word to ID. And we're going to get co-occurrence matrix. And C is pre-co matrix corpus. So this is our implementation, and we are applying these implementations to the PTB dataset. Okay. At this time, we're going to set verbose as true because it's going to take a lot of time. And after that, we can calculate SCVD. However, another point here is we should not use SCVD from NumPy because that's too slow. What we are going to use is a randomized SVD. It is an approximation to normal SVD, but it's much faster. And the usage is just same as normal SVD. And we can get word vectors as hue. Like this. And we can get queries, view, here are Yura and for query queries, most similar query word ID word X typo here and top 5. Okay. So when we run this, it loads the data set quite fast and it calculates the co-occurrence matrix and it takes quite a lot of time. However, PPMI takes most of the time. It takes about 4 to 5 minutes. And so I'm not going to just wait until this one finishes. You can run it on your own computer and try to play with this code block. And when you see this result, you might understand that even though count-based methods were traditional methods, but when you see this, their performance is quite satisfactory, quite good. Okay, so get the sense of how count-based methods can perform by playing with PTB dataset. However, when we increase the dataset to like that of Yahoo News or Wikipedia, then it might not be possible to calculate create co matrix or randomize SVD. But with PTB dataset, it's quite okay. All right.